All right, welcome back, fellow aircraft builders and aviation enthusiasts. This is part 3 of my top 10, if you will, scratch building concepts and recommendations. In the first video, we talked about a little bit about me and why I'm building an airplane and why I'm filming these videos for you and some of my thoughts about building an airplane. We went over my number 1 consideration, which is scratch building only if you really enjoy building things or enjoy the building process of an airplane, not, building just because it might be cheaper to get you into the sky. We talked about my number 2 consideration, which is thoroughly evaluating your production capabilities and your own skill set before you get started. In the part 2 of this video series, we talked about developing a project schedule that works for your lifestyle. We talked about the number 4 concern, which is staying organized is key. You definitely need to stay organized while you build this aircraft. And we talked about number 5, and number 6, which was not buying all your tools at once, and then that I recommend learning how to weld. So we're going to start this off with number 7. One of the recommendations I have, the number 7 recommendation here, is going to be that you source your materials locally. Now, I mentioned this in a video kind of all on its own. A separate video about buying metals, but it's an important point for this particular video. I highly recommend that you source your materials locally if you possibly can. There's a couple exceptions to that. We'll get to that in a minute, but one of the reasons for sourcing your materials locally is a good thing is that you'll save on shipping costs, and metals are heavy. It doesn't matter if you're buying aluminum or steel, it's heavy to ship, it's oversized to ship, and it's very expensive to ship. So you save on shipping costs, and buying locally helps support your local community, either whether it's within your state or buying locally from wherever you're from, that supports your local community. Another reason buying locally kind of helps is because you're saving on shipping costs, you're usually hauling stuff yourself. You can buy in more of a bulk quantity than you otherwise could if you were having it shipped. So buying in bulk typically will save you money. If you buy a single sheet of aluminum at $200, buying 2 sheets of aluminum in that same thickness, they might now only be $170 a sheet. Usually the price starts to go down dramatically the more you buy. I'm not really sure why that is, because at least for me, when I buy from my local vendors, it's a drastic discount the more you buy. So I highly recommend exploring that and asking about that. If you're buying from a local vendor, do they discount bulk purchases, especially from your large materials suppliers? You go down to your local hardware store and buy 3 sections of 4-foot square tubing, they're not going to discount that. But if you're buying from a large materials supplier, typically you'll get a bulk discount there. So the other thing to keep in mind when you're buying metals, particularly from local suppliers that supply lots of material like that, is metals are priced by market fluctuations. So similar to gasoline, the price will go up and down as the market fluctuates because it's a commodity, or precious metal is considered kind of a commodity item. So it is affected by market fluctuations. So keep that in mind. What you pay today could be different from what you pay tomorrow, good or bad. So with a couple of exceptions I mentioned earlier, the exceptions to buying locally are: 1, if you just simply can't source it locally. I cannot get 6061 T6 aluminum in 16 thousandths of an inch and 20 thousandths of an inch locally. It just isn't available. The major metals supplier that's around here, as well as some of the smaller ones that are close by, just don't have it that thin. So I have to buy it from Zenith Aircraft or Aircraft Spruce or Wix and have them ship it. Now, the benefit to buying that thinner stuff is they can roll it for shipping and ship it in a tube, and then it's generally a lot cheaper than crating it on a 4x12 pallet and trucking it here. So, but I have to break it up into multiple shipments, otherwise it just gets out of control. So, fortunately for me, I only have, I think, 4 or 5 more sheets of 20 thousandths that I have to order from Zenith. I believe I can get that in one shipment and call it good, and I'm done buying materials. But that's one exception. The other exception is a smaller quantity of metal, generally. So at the large mills or places that are selling large quantities of materials, they cut things to order for certain customers. So if you're buying a piece of 90 thousandths material that another customer bought a part of a sheet, The remainder that they didn't want is called a drop. And a piece of drop material is typically way, way cheaper, per square inch or per square foot than you would pay for the, proportionate price on a new sheet. So you can often find drops at your local materials dealers for very cheap and very inexpensive, but the other place you can find drops are at Amazon.com. I have an Amazon Prime account, and there's plenty of vendors online that sell drops for very cheap. I bought everything that was 93 thousandths and thicker in aluminum from Amazon.com for free shipping, or with free shipping, and you just don't need a ton of it. So I think the largest sheet that I had to buy was 18 by 36, and that was, I believe, the 93 thousandths, and I think I got that shipped to my door for $36, which if I was to buy a full sheet of that would be $300. So check Amazon.com. I'm not a big fan of, I do a lot of shopping online, let's be honest. I mean, I do a lot of shopping online, but I do still like to buy things locally when I can. Problem is, a lot of stuff I like to buy just isn't available locally. But so those drop prices with the retailers through Amazon, it was great. I bought a full, like, 1 foot square piece of 1/2-inch aluminum plate for like $12 shipped. Granted, I only need a tiny little piece cut out of that, but there's no way I was going to find any material like that locally without having to custom cut it, and then you ruin your savings. So those are the exceptions to buying locally, but I do recommend buying locally. That's number 8. So excuse me, number 7. So number 8 is a big one. Be prepared to make mistakes. When you scratch build an airplane, especially, but even if you're kit building, you're going to make a mistake. You're going to drill something in the wrong location that can't be fixed. You're going to cut something in the wrong location that you can't uncut. You might, in scratch building in particular, you might actually create a part that just isn't to tolerance, isn't to specification. You're going to have to make it. Don't beat yourself up. Be prepared for the fact that you're going to have to make and remake, and sometimes multiple remakes, a part, or a piece of tooling or a form block or something like that. Right here behind me, I mentioned these before. I have this is the form block for the nose rib. This is the cutting template for the part blank that gets formed around the nose rib, and then this is the nose rib itself. So I probably made 4 of these using this form block, which is correct to the drawing, before I had the right part, because I had to continually adjust this cutting template before this turned out correct. So a lot of things have to happen in sequence and in succession properly before you get a good quality part. Don't be afraid to remake a part. Don't be discouraged if you have to spend extra time, an extra 4 or 5 hours even, or 8 hours remaking this until it produces a part to specification. It's going to happen. There's no way around it. And I promise the more you do it, the better you get at it, and the less likely you're going to have a bad part. But don't be worried about it. Now, how do you decide whether or not your part is to specification or not? Well, generally speaking, aircraft manufacturers or kit manufacturers and aircraft designers that supply blueprints are going to give you some type of guidance as to what construction standards they want you to abide by. Zenith Aircraft in particular has like a whole library of resources on construction standards. I think their standard construction standards manual is about 30 pages long, but they have a whole library of stuff online that you can read for their aircraft. There are other textbooks out there. There's the Standard Aircraft Technical Handbook. The FAA has had for years, they've had Advisory Circular 4313. I'll put a link to that in the comments. These are acceptable practices for aircraft manufacturing and repair. So, in the Zenith aircraft, they tell you that, you should strive for a 0.5 millimeter tolerance in certain areas, a 1 millimeter tolerance in other areas, a 1/4 millimeter tolerance in other areas. So you'll know when you fabricate this part whether it falls within tolerance. Is the rib the right height? Is it the right, length from nose to mounting flange? Are the flanges wide enough? These are all things that the dimensions are given to you in the blueprints, but the construction standards tell you how much variation you're allowed on a certain part. So you need to know that information when you build these parts so that you can make them to the tolerances. However, don't focus on perfection. You're not building an airliner. You're not building a military jet. You don't need a perfect, CNC perfection. Like if you had a CNC mill and a CNC lathe and laser cut. Yeah, that's how how a lot of them make their kit and ship it to you, but you don't need to do that when your plan's building an aircraft. The construction standards tell you the standards you need to follow, and that's the only standard you need to follow. You don't need it perfect. It doesn't matter if it's off a little bit, as long as it's within the tolerances acceptable to the designer. And don't be afraid. And another thing, don't be afraid to remake your tooling. If you make a bending brake and it isn't performing the way that you like, make it over again, or take it apart and adjust it, or do whatever you got to do. There is a steep learning curve when it comes to fabricating parts for your aircraft. But once you start to get familiar with how the metal bends and how it forms and how it drills, you'll really start to speed up in your acquisition of new skills, and it's all going to build upon each next skill builds upon the previous one. So you're really going to start to get comfortable with things after you've cut that first metal. But it's a little daunting to cut into that first sheet of 4 by 12 foot sheet of aluminum, or make that first drill that first hole or set that first rivet. But as you progress, you're going to get a lot better at recognizing what's acceptable and what's not, and you always have those references to guide you. But you need to get a hold of those. You need to download them or buy them or whatever first, and really have a thorough understanding of what's acceptable and what's not before you get started. So, number 9, keep all your tooling throughout the project. I keep referencing these. The tools that you build to build your parts are called tooling. Holding fixtures, drilling fixtures, bending brakes, riveting fixtures. That is all called tooling. That is the tools required to build the airplane. So when you're all done making your nose ribs, let's say you made all the nose ribs for the airplane, don't scrap this wood and use it for something else, because several reasons. One is you're probably going to go through and make all the ribs before you make the wings. You have to do that. You need ribs to make the wings. So you're going to make 12 of these, 6 right and 6 left. And you're going to set them in a box or set them on a shelf and forget about them until you get to the point where you need them to assemble the aircraft. Things happen in a shop environment. Things fall from shelves, tools fall out of your hands, hammer heads fall off of hammer handles, you drop things tip over, stuff happens. If you no longer have this part, if you've scrapped it to make something else, or you've used it as a shim under your door or whatever, when you go back to try and remake one of these, you're going to have to make one of these all over again if this has been scrapped. And furthermore, the one you make is not going to be completely identical to the previous one that you made. So the new one, if I go back and try to make one of these exactly identical to this one, it's not going to be identical. And then I'm going to have maybe a slightly different nose profile for the 1 or 2 ribs that were damaged. And now my wings don't look right, or my airfoil is slightly different in a certain spot. So consistency is key. You need to hang on to this tooling for at least as long as it takes to build the airplane. I would argue hang on to it forever, because if you ever get into an accident, you run off the runway, or you get hanger rash, or you run into something in the, on the taxiway or the ramp or something like that, and you need to rebuild your wing, you're going to run into the same problem if you don't still have this to make that exact part. If I make another one of these off of this original form block, it's going to match this part. But if I have to make a new form block, it's going to be really difficult to match this entirely. So keep your tooling at least until you're done building the project. And my recommendation would be to keep it forever. Now, you can loan it to a friend if they want to build the same airplane, but I would hang on to it. All right, so number 10. This is the big, most important thing when it comes to scratch building an airplane. Number 10. If you're going to use an automotive engine conversion for your airplane, in my case, I'm using a Corvair, which is a car that was built in the 60s by Chevrolet. They stopped making them in 1969, so I'm building a 50, 60-year-old design, 50-year-old engine. I'm repurposing it for flight duty based on a proven method to do that. But there's other options for you out there. There's Volkswagen conversions, there's Subaru conversions, there's Honda conversions, there's Mazda conversions, there's Harley Davidson conversions. If you're using an engine, if you plan on using an engine that is not a regular airplane engine, so it's not a Franklin, it's not a Continental, it's not a Lycoming, it's not a the more popular Rotax or UL Power or Jabiru. if you're not using any of the airplane specific engines and you are going to use a conversion engine, do not start working on that engine conversion until you're very close to being done with your airplane. I'm going to get all anecdotal on you and tell a tall tale here, but I decided that I was going to build a Corvair engine for my airplane way back in 1999. I didn't actually get started on that engine conversion until roughly 2004, 2005. So I had this grand idea, and I've had lots of grand ideas that proved to be terrible throughout this process, but I had this grand idea that I was going to build my engine first, crate it, and then rapidly build my airplane and stick my engine in my airplane. And I had an engine ready to go. So it'd be better than any other way I could do it. I thought that that would make sense. Well, little did I know how long it would actually take me to build not only the airplane, but the engine takes a while to convert. And furthermore, when I decided to build the Corvair engine, it wasn't quite as mature of a design back in the early 2000s as it is now. There were supply problems with some of the custom parts that I needed. I had problems with local machinists, that needed to do some local work for me that I had to have done here. Locally, I had problem after problem after problem. And so, consequently, it's now 2016 and I still don't have my engine assembled. I learned very, very much the hard way that you need to build your airframe first and then worry about your engine. So generally speaking, most of your scratch built and kit built airplanes are designed around if they're designed around a specific engine, it's almost always they're designed around a certified aircraft engine. So there's many of those available. They're always going to be available to you. You don't need to worry about building one now or buying one now because it may not be available later. But most of the designs are designed around a horsepower rating and a weight of the engine, an installed weight of the engine. So there, generally speaking, will be multiple engines that fit the bill for that. So my advice is that you concentrate more on building your airframe and worry about your engine choice later. Now the Zenith designs accommodate a whole range of engines. I can put a Continental 0200 in it, I can put a Jabiru in it, I can put a Rotax in it, I can put a Corvair in it, I can put a UL Power in it, I can put a Subaru in it, I can put a Honda engine in it. I mean, if it's long as it's the same power and weight, range, I can put it in the engine or in the airplane. But there have been many examples over the last 10 or 15 years of people that have invested several $1,000s into an engine concept that became defunct. The company went out of business, and this applies to Corvairs, it applies to Subaru, Honda, you name it. V8s, V6s, all kinds of different options out there that have come and gone over the years. I purchased parts over the course of almost 10 years for my Corvair. And then sometimes, in one case, I actually waited over 3 years for a single part. So those problems are all in the past. And generally, if you're going to choose a Corvair engine conversion, it's a little bit better of a choice nowadays than it was back then. But or it's a lot better of a choice in my opinion. But the point is that it's an automotive conversion. These are small, businesses. These are small business owners. They don't have the production capacity or the legacy that the certified engine manufacturers have, like Lycoming, Continental, or even now Jabiru, Rotax. UL Power is new on the market, but they're pretty new. So, if you're going to use an automotive engine conversion, or at least that's your plan, fine. Lots of viable choices out there now, but those same choices may not be available in 10 years if it takes you that long to build your airplane. So I was pumping many thousands of dollars into getting my engine conversion, which was detracting from building my airplane. I couldn't afford to do both at the same time at that time in my life. So the engine project just kept stalling and stalling and stalling. And I'd already prepaid for these parts, so I didn't have that money to put towards the airplane. And so it just backfired. I almost shelved the project indefinitely. I mean, there were times when I just didn't care anymore. I wasn't going to build an airplane. There were times when I got so frustrated I was going to, I felt like I was going to go off the deep end at times over just trying to get, a single part for my engine conversion. So you could potentially run into supply problems. You could, companies can come and go. By the time you finish your project, the engine choice you have may not be supported anymore. There may not be a viable community of builders out there working on it. But factory and certified engines will always be available. New engines are going to come on the market that may be better than what's available now. If that engine then becomes the better choice, then you can use that engine. But start with your airframe first. Just don't worry about the engine. If somebody designed an airplane and there's an example of it flying, that means there's going to be an engine available for it at some point, somehow, somewhere. So those are my 10 recommendations for scratch building. I'm sorry this turned into a 1-hour total series of videos. I tend to be long-winded on certain aspects of this, so I apologize for the length, but this is information that I would have appreciated when I first started looking at building an airplane, and so I hope you enjoy or got something out of it. If you have any comments or questions, please let me know. If there's any other resources I can point you to, please let me know. Recognize I don't have all the answers yet. Still haven't built my airplane. I got my rudder here, but I've got a long ways to go. But with persistence pays off, and I've got about 75% of the parts of this airplane fabricated after about 350 hours worth of work, 330 hours worth of work, and 1/3 of that is spent on just tooling alone. So persistence pays off, and good luck with your projects, and we'll see you next time. Thanks for watching.